to this, I am going to take the output here. This is neutral, this is 220, this is 30 volt, but what happens here? I am connecting this to this and take here. Therefore, this is increasing, this is decreasing. Therefore, here 220 minus 30 is going to be 190 volt. So, by properly manipulating the connection of the terminals of the primary with the secondary terminal, even though the voltage, incoming voltage is 220 volt, with a transformer like this, I am able to have either 250 volt or 190 volt. In one type of connection, I can have 250 volt, 220 plus 30. In one type of connection, I am able to have 220 minus 30. So 190 volts. So from this itself, we can understand that a stabilizer can be made by having a transformer alone which has primary 220 and secondary 30 volt. By properly manipulating the connection, we can get an output of 250 or 190. That means if you are able to get 250, then that type of transformer, that type of connection, you can call it as boost. Suppose if you connect this way, this is being connected here and the output is going to be 190, then this type of connection is called as buck. Therefore, nothing, it's very easy to understand. A stabilizer has got a transformer only inside, but we have to manipulate the connections only between primary and secondary, so that either we can opt for boosting or we can opt for bucking. Or normal. If the input voltage is normal, we should be able to provide the same voltage to the equipment. Stabilizer should do that. That's what we are expecting out of it. When the input voltage is exactly 220, okay, feed it to the equipment. If it is going down, increase to 30 volt. If the voltage is going up, try to bring down by 30 volt. Therefore, by proper adjustment of the terminals, we can use it as a boost terminal, boost type of application or buck type of application. So that is what we are expecting. That's what I said in the beginning. The specification is this. A TV or a stabilizer for a fridge or for a alternate AC, air conditioner, it is able to accept. It's ready to work perfectly for a voltage of 200 volts to 40 volt. 220 volts plus or minus 10%. It is ready. But if the input voltage is going down, then only it is under stress. It may be spoiled. So we are putting in between a stabilizer, accept the voltage as it is, try to manipulate, bring out voltage as 220 plus or minus 10% by properly connecting, either for boost or for buck. You will be able to get definitely the correct voltage which is being accepted by any equipment. So this is the principle behind any stabilizer, let it be a TV stabilizer or a voltage fridge stabilizer or air conditioner stabilizer. Okay, this is about voltage. Coming to the point, power. We know that a TV consumes maybe 80 watts. TV may be consuming only 80 watts. And then a fridge may be consuming 400 watts. And AC may be consuming 1000 watts. So, for stabilizer 80 watts, for a stabilizer 400 watts, for a stabilizer of 1000 watts. The principle is same. This is working in this direction, in this way only. This is also working in this way. This is also working in this way only. But only thing is, the stabilizer meant for TV has to develop only 80 watts. Stabilizer which is meant for fridge, it has to develop 400 watts. Stabilizer for AC, it should develop 1000 watts. Like that, The principle is same. The stabilizer is going to be small for TV and little bigger for fridge and larger one for AC. This should consume 1000 watts. This should give out 400 watts. This should give out 80 watts. Therefore, when you are opting for this type of power delivery, the transformer size also will become little large. When the power you expect after a transformer is very high means larger transformer. Small power means smaller transformer. Therefore, we are supposed to design a transformer for a particular application. We have to calculate the current also. When we are connecting in a manner the top terminal to the bottom one of the secondary or to the top terminal of the secondary, we should be able to drive a particular current also. That design comes here. Suppose if you are able to use it for a television, only 80 watts. What is the current flowing through that? 80 divided by 220 is the current. 220 is the current. 80 divided by 80 by voltage will give you the actual current which is necessary for a television stabilizer. Therefore, 80 by 20 it will come to 1 by approximately 1 by 3. 1 by 3 means 1 by 3 ampere. 0.3 ampere. For example, I am telling 0.3 ampere. Therefore, this secondary should be able to generate a voltage of 30 volts but with the current of 0.3. You should design your primary and secondary in such a way. If the current is 0.3, the wire enamel wire, what you want in a transformer should be able to carry maximum of 0.3 plus or minus 50%. Let it be 0.3, 50% means at least 0.5 ampere you should deliver. 0.5 into 30, what is the power of the transformer? 0.5 into 30, that is going to be 15. The transformer is supposed to be 15 watts for the TV. Okay, the same thing coming to fridge, that is going to 400 watts. That is going to be 2 ampere approximately. The secondary should be able to 2 into 30, 60 watts. You should select a transformer which should have primary and secondary. The power of the transformer should be at least 60 watts. Like, if we move on to air conditioner, that is 1000 watts. What is the voltage? 30 volt. What is the voltage? 230 volt. 220 volt. Is going to be approximately 5 ampere. So what is the power of the transformer? 5 into 30. VA is the power. Therefore, 150 watts transformer is necessary. So from this, I would like to conclude. I have discussed about the necessity for a voltage stabilizer, for a TV, for a fridge and for a air conditioner. That is because incoming voltage from the substation is not going to be constant. It may be sometime going above 240 or sometimes it may go down by 200. All these things are producing some difficulty in the performance of the television and the fridge and other things. It may fail. It may burn out. Therefore, a stabilizer is a must for these equipments. The stabilizer is supposed to accept the fluctuating voltage and give out a constant voltage which is necessary. I told you. And then at the end, I told you how it can happen. That is by opting for a transformer which is having a secondary of 30 volts or something. By properly manipulating the connections of the primary and secondary, and you can use that transformer as a boost transformer or a buck transformer, so that considerably what is required by a equipment, that voltage can be fed to the equipment. That will be safeguarded. But one more thing, they have to take care of the power of the equipment also. Equipments what we use are not having the same electrical power. They are having only 80 watts, 400 watts, or 1000 watts. Like that, power is changing. When the power is changing, accordingly we have to design our stabilizer, AC voltage stabilizer. Therefore, we are connecting this and that. We are able to safeguard these equipments. With this, I want to conclude, and practically how connection is done using the relays, the transformers, with the transistors and everything. In the next part, I will be discussing about it. Until then, bye. This is Dr. Ram. Thank you.